Alright, dear children of class 11 science, we do now continue again with this concept that you learned in the last YouTube video, the capillary rise you learned in the last YouTube video. Now in this particular video we come to the derivation of Ascent formula. Okay, now as for the capillary rise, okay, which actually due to the forces which exert vertically upward to every unit length of the periphery of the meniscus, which is formed inside the what tube, when that tube is dipped in a liquid. Okay, now in order to derive the formula called Ascent formula, okay, so let me just take the same glass capillary tube. Let me take the same glass capillary tube with same diameter, same uniform, what means uniform is only called same internal radius, and that radius I consider say r is the internal radius, and this tube is placed vertically. So this tube is placed vertically in water, and which is lowered and is dipped into the water. So this is the lower end of the tube which is dipped into the water. But we consider that when we dip this tube, that is called capillary tube, in the water, this is water, we are taking this as water, and this tube has a radius which is r, and this is what tube we call capillary tube. Capillary what tube? Then we consider that there is a rise in the what level of liquid, or this means the rise in the level of water inside the what tube, and due to this rise in the level of water inside the tube, there is a meniscus which is formed. There is a meniscus which is formed inside the tube, and this finally which meniscus is formed? Concave meniscus. But this meniscus is formed throughout the diameter of the what tube. Okay, so that it formed the meniscus almost this way. So I am making with the help of a dotted line. Okay, so I consider this is the meniscus, concave meniscus which form inside the glass tube, that is called a capillary tube. Okay, but in this capillary meniscus which is formed throughout the tube, okay, there is a upward force. There is a what force? Upward force which exerted per unit length, and it exerted total length of the periphery. Total length means also called the periphery of this what concave meniscus, and this force is actually like vertically outward, and this force is given by 2 pi r t cos theta. See, we have already calculated 2 pi r t cos theta in the last YouTube video, and this is the total vertical component of force which act on the entire circumference. This is the entire circumference of this meniscus which is formed inside the what tube. Okay, so due to this force, consider there is a rise in the level of what? Water inside the what tube, and consider the rise in level of water is at a height say h from this surface, and this surface is called what surface? Free surface. So under this case, children, we can derive a formula called Ascent formula. So children, I have already made the assumption out here that small letter r is the symbol I am using for internal resistance. Radius of capillary tube. It's not resistance, sorry, this is internal radius of capillary tube. Okay, and once this tube is dipped into the liquid, okay, then the liquid like water, the water rises to the capillary tube to a height say h, and that we have already seen in the diagram also. Okay, so under this case, what happened? There is a total upward force that exerts on the periphery of this meniscus which is formed inside the what tube, and that total upward force, I don't know, the total upward what force, okay, acting on the periphery, acting on the what periphery of meniscus. Actually this is the periphery of meniscus formed inside the tube, inside the what tube, and that total force I consider is F, and this total force, as you can see, is how much? 2 pi r capital T cos theta, and this is the total what force? Upward force or vertical force, and this is the vertical component of force or the tension which is acting on the what periphery of the what liquid, or that is the periphery of the water that is formed inside the what capillary tube. Okay, now out here you know theta is what? Angle of contact, and T is the what? Surface tension, okay, of water. Now in equilibrium, basically what happened in equilibrium, Okay, now in equilibrium, this upward force you can see is exactly balanced by the weight of water column that will be raised inside the tube. So in equilibrium, what happened? The upward force is equals to the weight of what? The weight of water column. Weight of water column. Okay, weight of water column raised inside the tube. Raised inside the tube. Inside the tube. Now, in order to calculate this weight of water column raised inside the tube, that is called capillary tube, we follow figure number 3. So let me show you figure number 3. So in this figure number 3, children, if you look at this figure number 3, okay, there is a meniscus which is formed, convex meniscus, but with respect to this point at the center, or also called the axis of the tube, okay, this tube has a radius, what is r, okay. So what I do, I consider this curve. I consider this what? A curved surface, and this curved surface again I mark by letter, say A, E, B. Just marking by what? A, E, B. So this is the curved surface of this meniscus which is formed inside the tube. But this curved surface of the meniscus is actually the hemisphere. You know, hemisphere whose radius is what? R. Okay, hemisphere whose radius is what? R. Like bowl. Okay, so bowl is the shape of hemisphere. Okay, and that hemisphere has radius what? R. Okay, and this hemisphere whose radius R is taken equals to the radius, or whose radius is equals to R, as I said already, of the what tube? Capillary tube. Now to calculate the volume of the liquid, column raised in the tube, that means this tube, again according to the same height, okay, I consider the height is how much? H, the same height, but the height which we measure out here is measured from the lowest part of this meniscus which is formed inside the tube. So we take from this base surface of the meniscus, okay, to the surface, the free surface of water, that is contact with the what? The tube. Now, as I said already, to calculate the volume of the liquid that contained in this tube up to this height, and this volume that we calculate, okay, that is the volume of liquid filled, okay, or raised in the tube, okay, is actually equals to the volume of liquid filled in the cylinder. Actually, this tube is usually what in shape? Cylindrical shape. Filled in the cylinder of height what? H. Okay, plus the volume of the liquid filled in this curved surface, that is the curved surface means AEB. Okay, and this curved surface is basically the surface like hemisphere. Now children, we calculate this volume of liquid, okay, in the cylinder of height H, and also we calculate the volume of liquid filled in the curved surface AEB. So for that, let me show you again that figure, figure number 3. In this particular figure, figure number 3, see the height up to which the water has been raised, actually from the base of this meniscus, from the free surface I have already considered H. Okay, but this is the curved surface which is formed by the meniscus, and this radius is R. So if this radius R means this distance, the height in which the meniscus is formed is also what? R. So this is R. Okay, now I have drawn a dotted line, if you see, and this dotted line means this is the height up to the base of this meniscus, where we can use the formula to calculate the volume of what? Cylinder. Okay, to measure the volume of what? Cylinder. So for that, let me just consider this is A, this is B, say this is say C, and this is what? D. So A, B, and this end is what? C, this end is what? D. And this radius is also, this is also equals to R, but this R is also the height of this curved meniscus which is formed from this base. Okay. Now in this particular formula we use the formula to calculate the volume of liquid that is filled in the cylinder up to the height what? H. Okay. So up to this what? Tube. Up to the what? Up to the level, okay, of meniscus inside the what? Tube. But as I said already, the formula is volume of what? Liquid raised in the tube is given by volume of liquid filled in the cylinder of height H. Now volume of liquid filled in the cylinder up to height H is also the volume of cylinder. And you know what is the formula of volume of cylinder? Pi r square H. So the formula is pi r square H. If the cylinder acquire a height H in which the water is contained, okay, and the radius of cylinder is r, then the volume of cylinder is given by pi r square h, plus the volume of liquid filled in the curved surface AEB. Means we need to calculate the volume of liquid filled in this much curved surface only, AEB only, this much curved surface. But how to calculate the volume of liquid filled in this curved surface AEB? So this can be calculated as the volume of cylinder, that is ABDC, the volume of cylinder ABDC, okay, minus the volume of hemisphere, because this surface is usually what? Hemisphere. Okay, this surface is called what? Hemisphere. So the volume of cylinder ABDC minus volume of hemisphere, measure the volume of liquid that is filled in this curved surface. Now we can substitute the value of this volume of cylinder ABDC and minus the volume of hemisphere AEB. Okay, so the formula is now pi r square h, the volume of cylinder. The volume of cylinder ABDE means that cylinder has height equal to radius and is given by pi r square. The radius is r square only, but the height in which the curved surface this cylinder is formed is called r. Okay, I mean we have calculated the volume of this cylinder, this much height. The height of the cylinder is r, the radius is also r. That's why the volume is given by pi r square r, minus the volume of hemisphere, and the hemisphere formula is what? Just volume of hemisphere is just half the volume of what? Sphere, and the volume of hemisphere is given by 2 by 3 pi, and the radius is what? r, and with q. So this is the volume of hemisphere. So let's simplify this for the pi r square h plus pi r cube. This pi r cube minus 2 by 3 pi r cube. Okay, now we can simplify this again. So pi r square h. Now if I take LCM and of 1 and 3, the LCM is what? 3. So 1 divided to 3 is 3. 3 into pi r cube means 3 pi r cube, minus 2, 3 divided by 3 is 1. 1 into 2 pi r cube means 2 pi r cube. Okay, so it will be now how much? Pi r square h plus 3 minus 2 means what? 1. So this is simply how much? 1 by 3 pi r cube. Now children, in the expression you can see there is a common, so I can take common is pi, and r square r cube common is r square. So inside the bracket r h will remain plus 1 by 3. Now pi already taken out, and r square from r cube, if I take r square, then it will be what? R. So it's pi r square bracket h plus r by 3. Okay, now finally this is the volume of what? Liquid filled in the cylinder up to that raised to the volume of liquid column raised in the what? Tube. Now after calculating the volume, now we calculate the what? Weight. But before I calculate the weight, I consider that liquid has a density, and density of the liquid is rho. So let rho be the density of liquid, and the liquid we are taking is what? Water. The density of water filled in a tube. So to calculate the what? Weight. Now I calculate the what? Weight. The weight of liquid. I calculate the weight of what? Liquid column raised in the tube. In the what? Tube. And this weight of liquid column raised in the tube is equals to mass into gravity. Mass into gravity. Gravity means what? G. But mass means what? Volume into density. Mass means what? Nothing but volume into what? Density. Into the gravity is what? G. And this gravity is called acceleration due to gravity. Now this volume means the volume that we have calculated just now. That is how much? Pi r square h plus r by 3. This is the volume of the liquid raised inside the tube. And density of liquid, we have already considered what is the density of liquid? Rho and G. So this is the weight of liquid column raised in the tube. Okay, but as for the relation, I have already expressed that in equilibrium the force is balanced by this weight. Okay, so I write down now, therefore in equilibrium, okay, the force, and that force we have already calculated as 2 pi RT cos theta. And this force is exactly equal to the weight that we also calculated, which is pi r square h plus r by 3 rho into what? G. Okay, so in the expression now see pi and pi cancel out. Okay, pi and pi cancel out. R and 1 r square, r will cancel out. Okay, now we cannot cancel further. Okay, now let me just make t as the subject. If I make t as the subject, on the right hand side it will be how much? R, this r, bracket h plus r by 3 rho g, okay, rho g, okay, by this 2 and cos theta will go in the remainder, 2 cos theta. So T, this T means the surface tension of the water is given by R bracket H plus R by 3 rho G by 2 cos theta. Okay. Now, this is the general formula that measures the surface tension of the water exerted exerted by the water, okay, in that tube. And this surface tension can be calculated in terms of height and the radius of the what? Tube. But I do the consideration that h, the height in which it acquires, is basically large compared to r by 3. You know the radius of the tube is very small, but r by 3 is also very, very small. But the height of water raised inside the tube, if it is very large compared to r by 3, then definitely this r by 3 will be neglected. R by 3 is simply neglected. And children, you know what is neglected? Is almost 0. That is almost 0. This value we can almost consider to be 0. So under this case also, your surface tension can be calculated as R H plus, now this quantity becomes 0, rho G by 2 cos theta. So you can see another expression that we can have for surface tension of water, that is R H rho G by 2 cos theta. T equals to R H rho G by what? 2 cos theta. Okay. Now, in this expression, we can measure the surface tension of what? Water. Or it is also true for the surface tension of any liquid. Okay. But this surface tension can be calculated in terms of the height in which the liquid or water is in the tube, in terms of density, the gravity, and also important is that this surface tension also depends upon the angle of contact between the plane surface, the tube and the glass tube, and the what? The level of water. And this expression is actually for ordinary water. Okay, what water? Ordinary water. But if I consider a water as a pure water and the glass tube is a clean glass tube, in that case theta is considered to be how much? 0. 0 degree. Yes, the angle of contact for pure water and clean glass plate is how much? 0 degree. So if this is 0 degree, then what is the surface tension? So T is also given by RH rho G by 2 cos 0 degree. And you know cos 0 degree value is 1. So it will be RH rho G by what? 2. So children, you can see the expression that the surface tension of pure water and clean glass plate can be even calculated as RH rho G by what? 2. So by determining the height in which the water level rests in the tube and knowing the radius of the tube and the density of water, then we can easily calculate the surface tension of pure water. We can calculate the surface tension of which water? Pure water. So children, this particular formula that determines the surface tension of water or liquid, okay, in terms of the height, is also called as Ascent formula. This is also called what formula? Ascent formula. Okay, so I have explained in detail about the derivation of Ascent formula, and there are some numericals that we need to do based on this Ascent formula, and that you learn in the next YouTube video.